You ever wonder about the invisible chemistry that's running, well, basically everything? From why a lemon is sour to the actual nuts and bolts functions that keep you alive, there's this secret balancing act happening all the time. Today, we're going to pull back the curtain on one of the most fundamental ideas in all of science, pH. And believe it or not, it all starts with a kind of weird question.
I know, it sounds like the setup to a really bad joke, right? But the answer connects these totally different things in a way that's actually, well, pretty amazing. They all live on a chemical spectrum, and if you can understand that spectrum, you've got the key to understanding how our world, and yeah, our own bodies really work.
So where do we even begin? Well, it all starts with the most common thing on Earth, water. But you know, water is way more interesting than we give it credit for. On a microscopic level, it's doing this constant hidden dance with itself.
Okay, so take a look at what's happening here. Water molecules aren't just lazy bumping into each other. They're actually reacting. One water molecule can pass off a proton to another one. And when that happens, bam! You get two brand new super important ions. Hydronium, which is our acid player, and hydroxide, our base player. This little exchange is the foundation for everything else we're about to talk about.
This whole process has a name, self-ionization, and it's happening right now in every single drop of water on the planet. So even in the absolute purest water you can find, there's this perfect, delicate balance going on between those acid and base ions. They're in total equilibrium.
So how many of these ions are we talking about? Well, in pure water, the concentration of each is this number. It's basically 1/10,000,000th of a mole per liter. I mean, it's an incredibly tiny, and let's be honest, a really awkward number to use in conversation. Chemists needed a better, simpler way to talk about this.
And that better way is the pH scale. It's this absolutely brilliant solution that takes those tiny, clumsy numbers and translates them into a simple, easy-to-use scale that just goes from 0 to 14.
At its heart, that's all the pH scale is. It's a tool for convenience. It takes that scientific notation gobbledygook and turns it into a simple ruler that lets us measure how many of those hydronium ions are in a solution on a scale we can actually wrap our heads around.
And this scale just lays it all out, nice and easy. Way down at one end, a pH of 0 means something is super acidic. All the way at the other end, 14 is super basic or alkaline. And right there, smack dab in the middle at 7, that's perfect neutrality. That's our pure water, where those two ions are in perfect balance.
So what really makes something acidic or basic? Just think of it like a seesaw. It's all about tipping that balance we saw earlier. If you have more of the hydronium ions, the acid players, the solution becomes acidic. If you have fewer of them and more of the hydroxide ions, the base players, it becomes basic. It's just that simple.
Okay, let's see how this actually plays out in the real world. That gastric juice in your stomach? Whoa, it's incredibly acidic, down around a pH of 1 or 3. 11, also pretty acidic, around 2.3. But then look at this. Your own blood is just a little bit basic, hanging out right around 7.4. And then way at the other end of the spectrum, you've got something intense like drain cleaner. All of a sudden, these numbers start to mean something, right?
And that number for blood, 7.4, that is not just some random fact. That is everything. This is where we go from basic chemistry to the really high-stakes world of biology. Because it turns out that for us, life exists on a chemical razor's edge.
So why is that razor's edge so critical? Well, it's because of these little things called enzymes. Enzymes are the microscopic workers doing all the jobs in your body, building things, breaking them down, making reactions happen. But here's the thing, they are incredibly fussy employees. They need the conditions to be just right, or they won't work at all.
See, for an enzyme, its shape is everything. That's what allows it to do its job. But the forces holding that shape together are super sensitive to pH. If the pH in your body shifts just a little bit, those enzymes change shape and they just stop working. And if your enzymes stop working, the entire chemical factory that is your body grinds to a halt.
So how on earth does your body stop that from happening? How does it keep that perfect pH balance, even when you drink a glass of acidic orange juice? Well, it has this unbelievably cool and elegant solution, something called a buffer system.
This right here is the magic number. Your blood has to be kept at a pH of around 7.4. If it drops to 6.9 or goes up to 7.6, that's it. It's life-threatening. That is an incredibly narrow window with basically zero wiggle room. And here is how your body pulls it off. As your cells do their thing, they make carbon dioxide. That CO2 dissolves into your blood and creates a natural buffer. This buffer system is like a chemical sponge. It instantly soaks up any extra acids or bases to keep the pH from changing. And the master controller for the whole thing? Your lungs. By breathing faster or slower, you change the amount of CO2 in your blood, fine-tuning this whole life-saving system with every single breath you take. It's amazing.
So let's just take a breath ourselves and recap this incredible journey. From a single water molecule all the way to the complex chemistry that's keeping us all alive right now.
Okay, here's what you've really got to remember. First, it all starts with water splitting into those acidic and basic ions all by itself. Second, the pH scale is just the simple 0 to 14 ruler we use to measure that balance. Third, and this is the big one for us, our body's enzymes are super sensitive to pH. And finally, our body has this genius buffer system hooked up to our own breathing to hold our pH steady at about 7.4 and, keep us alive.
It is pretty incredible when you think about it. Your body is the silent, invisible chemical factory, performing thousands of these little balancing acts every single second, and you don't even have to think about it. It just works. So it kind of makes you wonder, what other amazing balancing acts is it pulling off right now?